4.11 is the last section, and this is the same solving trig equations, but the main strategies for you guys to utilize is just, it's exactly the same way that you would solve the quadratic equations. Only difference is instead of just simple one variables, and then we will see trig function variation in each equations there. Okay, so let's start it. The first example, solve 2 sine square of x plus 3 sine x equals -1. And let's focus on what condition that we're given with. So the angle should be between, it was usually 0 to 2 pi, but now it has to be only pi to 2 pi. So based on the experience before, and even if we can find any possible angles, and then if it's not within pi and 2 pi, and we cannot even include them as the answer, but we will see, okay? So now let's solve the equation first. So notice that this equation only uses a sine function, and then it's simple. That's good news. That's good news. Then we can go ahead and move the numerical term from the right side of the equal sign to the left side so that we can have all 3 terms so that we can trinomial factoring there. So if I add 1 here, 1 there, then I will have 2 sine square of x plus 3 sine x plus 1 equals 0. Then, since this is a first problem solving, and I will show you how you can replace sine of x into simple uppercase letter so that you can see clearly just quadratic equation structure. If you're already familiar to this strategy, because we already did a few times, honestly, but if you rewrite it with the simple familiar variables, and then it kind of gets rid of the distraction, so it might help. So then let uppercase A be sine x. Then I can simply rewrite just quadratic equation goes to a squared plus 3a plus 1 then equals 0. Then we can factor this next step. And then the factors of 2a squared is 2a and a. And factors of the last term, 1 is 1 and 1. 1 and 1. Then I can already see it's simply plus 1 and plus 1. How do we know? We can check 1a and 2a definitely makes 3a. So it's checked. Then we can solve from there. So 2a plus 1 is 0. Then we have to do separately in each parenthesis. Then a plus 1 is 0. Then first equation, a is subtract 1 from both sides, divide by 2 will be -1/2, right? And then the second equation, a is -1. But you have to remember the a is not actually the a. We rewrote a being sine of x. So then let's go back to original. So sine of x is 1/2 and sine of x is -1. Then let's have our unit circle reference here. Then what angles will get sine -1? between pi and 2 pi. So since we have pi to 2 pi, only from here all the way here. So then I do see 3 pi over 2 is where sine is -1. Okay, so then here x for this between pi and 2 pi is 3 pi over 2. Then what angles that get sine -1/2? Here's one, 11 pi over 6. And I will check one more time, and there's one more, 7 pi over 6. And definitely both are with sine as -1/2. Then I have two more angles. Under here, x could be 7 pi over 6 and 11 pi over 6. Okay. Then all three happen to be within the condition here for x between pi and 2 pi, and we can include all of them. So this is okay, this is okay, and this is okay. Okay, so those are the answers. All right, and then let's save it. And number 2. Do you guys have any questions by any chance? Excuse me. Okay, this is number 2. Okay, now notice the quadratic term in the beginning of the equation is secant, and the midterm is 1 over cosine. They look different, but we already know they are the same because 1 over cosine itself is secant. Now, this is not tricky. This is actually secant of x, right? So then it's simple. And since we know that, we can rewrite this equation down here, 2 secant square x plus, instead of 1 over cosine x, I can write 3 secant x. And just like previous example, that we would like to have all three terms in my left-hand side. So -2 will get us 2 as negative on my left-hand side. And then the other side is 0. Then we can solve. We can factor and solve it. Then since we went through the steps that we can replace the trig functions with a certain letter, and we can just try directly for number 2. So now my parenthesis is a little bit wider because I know for sure that I have to write the secant x there. So the factors of 2 secant square of x is 2 secant of x, and then the other factor will be secant of x. Then what are the factors of 2? 1 times 2. Then our goal is we're making 3 secant x in the middle. So I have to rearrange 2 and 1 in here. This is 2, so that if I multiply this way, it's 4 secant x. And then 1 goes in here, so that this is secant x. But in order to make 3 secant x, this is subtracting, this is positive 4 secant. So this is definitely 3 secant x, right? Then it's done. Then now we separately solve the each parenthesis. 2 secant of x minus 1 is 0. And the second parenthesis is secant x plus 2 is 0. Then let's solve it from the left side. So then the left one will be add 1 to both sides, divide both sides by 2 will get us secant of x is positive 1/2. And the second question will be secant of x is negative 2. But in order to utilize the unit circle, we better convert this secant into cosine so that I can verify the angles directly from the unit circle. Then all I have to do is I have to flip, right? Then if I reciprocal secant, and then it's gonna be cosine x being reciprocal of 1/2, it's 2, and cosine x is negative 1/2 now. Then remember, now cosine x is 2 is undefined. Why? From the parent function graph of cosine, x-axis, y-axis, it was 1, negative 1, 1. So if you remember the graph of cosine, I mean, you can verify it in various ways, but I always utilize these graphs because it's visual, it's right there. It only goes up to 1. It only goes down to negative 1. So between 1 and negative 1, and then it would not go higher than that or lower than that, right? So right there. So this is 1 and negative 1. So this is undefined. This is impossible. So then it's undefined for x. It's not possible for us to get the angle measure that satisfies the equation there. Then what about the second one? Yeah, of course we can find it on unit circle. So which angle is that? The first one would be 2 pi over 3. That's definitely the cosine negative 1/2. And then another one is 4 pi over 3, right? So then here, the one thing that we have to remember is the condition for x being all possible values. That means we have to consider there's gonna be repetition every time we circular over the unit circle over and over, right? So then the quickest way for you guys to make that rule there, the first angle, 2 pi over 3, and then it's gonna go positive way and negative way. Every time you pass 2 pi more with n indicates all the integers, then you will hit the same spot, right? Then the next angle is 4 pi over 3. Then it's the same manner. I can utilize 2 and pi, positive and negative. And then in this case, n is integers. Every time it goes 1 more or 1 less or 2 more or 2 less pi, right? And then that's exactly the same place that you hit that angle position there, okay? Questions? All right. Okay, then now number 3. So 4 cosine square of x minus 3 equals negative 1 for all values of x. Okay, again, since this one is not limited and restricted as domain, then probably we will come up with the rule for the answer. Okay, let's see what happens here. Then first, we have to solve this equation. But this one is a little bit different from trinomial equation solving. We would not utilize that as the factoring. You can just put the numerical term to the other side, and then you can utilize square root both sides, right? Then first we will add 3 and add 3. Then it's gonna be 4 cosine square of x, and then the other side is 2. Then divide both sides by 4 will be cosine square of x, means 2 over 4, and then it's also 2, just 1 over 2. Then square root both sides, square root both sides. But what you need to remember is when you square root both sides, this is always cosine without square now, but you have to remember it's plus minus square root of 1/2. You always have to put one plus minus in front of the square root. And then this is the same as plus minus radical 1 over radical 2, which is plus minus 1 over radical 2. Then, as you remember, we might have to rationalize the denominator by multiplying top and bottom by the denominator radical. Radical 2, it's plus minus, what is it? Radical 2 over 2. Then this is the exact value that everybody knows. It's 45, and then pi over 4 here, right? But this is also the double because it's all inclusive, it's positive or negative. So let's see the position covers everything. Here, there, and then it's all positive or negative. So consequently, we're supposed to write pi over 4 plus minus 2 and pi. 3 pi over 4 plus minus 2 and pi. 5 pi over 4 plus minus 2 and pi. 7 pi over 4 plus minus 2 and pi. It's totally fine. So let's write all of those candidates. In this case, as you see here, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and they are either positive or negative. Radical 2 over 2 for cosine, right? So, but because of the condition goes all values of x, and we have to write in rule. Excuse me. Okay, then we could write pi over 4 plus minus 2 and pi. 3 pi over 4 plus minus 2 and pi. 5 pi over 4 plus minus 2 and pi. 7 pi over 4 plus minus 2 and pi. And where the n? N integers, right? But realize if you start from pi over 4, and then let's change the color. If you start from pi over 4, and then you go pi much, and then you automatically hit 5 pi over 4, right? And then you also start from 3 pi over 4, and you go pi much, and then you automatically hit 7 pi over 4. And then if you go pi more, and then it's gonna keep hitting the same spots. Then in order to be more efficient, it's still same rule applicable if you say from the pi over 4 plus minus not 2 pi every time, just pi every time. And from 3 pi over 4, every time you go pi more or pi less, so it's n pi and then n integers again, then technically either way, they're the correct answer. Consequently, it's gonna hit the exactly same angle positions every time you follow the rule. So either way. But every time you solve certain problem, and it might be given with a certain type of answer choices only. So that's why I'm showing the both ways, okay? All right, how about now? Any question? This problem was a little bit complicated. I hope you guys revisit this video later so that you can understand everything step by step. Okay, so we have one more example left. Number 4. Okay, ooh, the given equation is already long, but let's observe what we have here. Now I notice there's secant square, and then there's also the tangent languages, and then a lot of radical 3's and 3's. So instinctively, the trig identities for us to utilize here is secant square and then tangent and all those. Pythagorean trig identity group 2 might be very, very handy, right? Okay, so recognize secant square of x can be rewritten as a tangent so that we can unify every term with just tangent only, right? So I can start rewriting this equation. The first secant square will be 1 plus tangent square x. So here, 3, oh, okay, let's go back to pen. 3 parentheses, instead of square, secant square, it's 1 plus tangent square x, and then negative 3 plus radical 3 tangent x. And probably it could be a good idea that we transpose everything to one side. So it's going to be negative 3 oh, it was negative. Tangent x, negative 3 tangent x minus 3 is 0. Oh, it's radical 3. Okay, then let's distribute. This is 3 plus 3 tangent square of x minus 3 plus radical 3 tangent x minus 3 tangent x minus radical 3 equals 0. So now what we have to do is recognize like terms and combine, right? Then good news, there's some terms to cancel. So now I notice 3 there, negative 3 there. And do we see any more like terms? Oh, here, this is tangent x and that's tangent x, but the coefficients are different, right? But we can still combine them by factoring the tangent x out. So it will be rewritten as this order, 3 tangent square of x. And then now 2 terms, then it's going to be plus parenthesis radical 3, but this is negative 3 tangent x minus radical 3 equals 0. So So now we have weird form of trinomial, but notice this is still the trinomial format. Then I can still factor, because the factors of 3 tangent square will be 3 tangent x and tangent x. And the factors of radical 3 is only 1 times n radical 3. So all we have to do is we have to put the factors of radical 3, which is 1 and radical 3, brilliantly so that we can come up with this. So the last position I need -1 so that it will make -3 tangent x. And in front of tangent, and then it has to be positive radical 3 so that it makes this part radical 3 positive with the tangent, and we're done, right? So then let's solve it. Here, first one, subtract radical 3 from both sides and divide by 3, and then it will be tangent x negative radical 3 over 3. Then second one is easy. Tangent x is positive 1, right? Then here, in order to find the angle x that gets tangent negative radical 3 over 3, we might have to think further. Here, this might have been rationalized. So if you can go back, the status it was before the rationalization, it must be -1 over radical 3. So imagine yourself that you multiply radical 3 top and bottom, and then it could go back to be negative radical 3 over 3 right there, right? So then this is easy. We already had a couple of examples, what angles that gets tangent -1 over radical 3, right? Then we can just continue to find the angle first, and then tangent equals 1, right? Then now all we have to do is find the angle. So then let's pull the unit circle reference here. That's where tangent becomes 1, positive 1, right? And there's one more, where sine and cosine are the exactly same value. Top and bottom will make tangent 1. And then there's the other 2 angles that get tangent -1 over radical 3. So that's 5 pi over 6 and 11 pi over 6. So here, again, once you start from pi over 6, pi more, it's gonna hit another angle. Then if you start from 5 pi over 6 and just pi difference, and then it hits another angle. So in this case, the making rule is a little bit less complicated. All we need to have here is from starting pi over 4, positively, negatively, every pi, it's gonna hit all the possible angles. And from 5 pi over 6, positively, negatively, every time you go pi further, so it's going to be multiplied by the integers, and it's going to hit all the possible angles x. Then we define n being integers. Okay, then that's all we need right there. Okay. How is it? Any question?